All right, so hi all. Kelly and Amruta here, and we both work for TRC. TRC is a environmental consulting company, and we are also implementers. So we implement programs for utilities, different parts of United States, and maybe even outside. But today, between Kelly and I, we have some pilot programs going on, all cutting edge, around electrification and load management or load balancing. So our presentation is going to be around, we are going to first 15-20 minutes, Kelly and I, we will cover the pilot programs that we are both working on, and then the last 10 minutes are for question, and we'll keep the last 10 minutes for more of a discussion. Okay, how do I proceed the slides?
You ask a lot.
Okay, all right. The objective, or what we are going to cover today is need for behind the meter load management. Should I start this? Maybe stand this way. Okay. Behind the meter load management and why load management is critical as electrification and is becoming critical for utilities and clients across the country are projecting more electrical load growth. How do we electrify and minimize grid impacts? Can you electrify and still minimize grid impacts so that the utilities don't have to upgrade their infrastructure? That becomes expensive, and where are they going to get all that money from? And that goes pushed back to us, customers. And then finally, as I said, we have three efforts that we will talk about between us. Next slide, please. So what is the need for behind the meter load management? As I said, electrification is increasing, and utilities around, even in fact around the world are seeing higher demand in the residential, commercial, industrial, even transportation sectors. And they are looking for ways to expand their electrical infrastructure with flexible loads. Per the latest study by NREL, electric vehicles or heat pumps, the increase or the deployments of these electrical technologies is going to increase electrical demand by about 40% by 2050. That's a big number. And how do you achieve that without upgrading your electrical infrastructure? So that's one of the biggest questions in front of the utilities. So advanced technologies that are flexible or that allow flexibility, load balancing or load management is going to be critical. Not just advanced technologies, but having those technologies cost effective and ways for scalability is another question that we are trying to solve. Next slide. I guess, so this is the first pilot. I'll pass it on to you because that gels very well.
So let's just put some numbers on the potential costs or savings, depending on how you look at it. If we do things smartly when we electrify behind the meter, or whether we just do it business as usual. So if somebody's told, oh, I want to electrify my home, you need to upgrade your panel, it's going to cost the homeowner, if it's just the panel, up to $5,000 before they've even started electrifying anything. So that's expensive on the homeowner and often a deterrent. But then sometimes the service coming into their home is not adequate. That can add another few thousand, and if you have an underground electric line, it's much bigger. It could even be 10,000 with all the trenching, and a lot of that is paid for by the customer. But then if enough homes in a neighborhood do that, then the transformer needs to be upgraded by the utility, and then eventually the generation needs to be updated, and of course all of that gets sent back to the ratepayers. So these are some big numbers. So anything we can do back in the beginning to see if we can get electrification done without increasing the panel size is a very big deal. Next slide. So there's a bunch of us that are here, actually, that are working on a CEC grant program. Hi, Dylan. That is really pretty cool. You may have heard of the Watt diet. Redwood, of course, and Tom Cabot, and lots of folks have been using it. It's essentially a spreadsheet level tool at this point. The idea is can we take it to the next level and make it something that's more mature, more reusable by other folks that aren't as much into the wonky details. And so there's a CEC EPIC program. It's 3.5 years long. We're about half a year into it, so it's going to take a little while to get it done. But the idea is to develop an open sourced online tool. And the idea is there's an engine, the blue at the bottom, that is doing all the math and taking in all the data tables and whatnot. We have LBNL doing that part of it. And then there's a UI that sits on top of that that Quick Carbon is working on to really be the interface to that engine and make it more usable for folks, whether it's homeowners, contractors, whoever it is in the ecosystem. There's a bunch of field trials that we're going to be doing, and that's where TRC comes in. We are leading the field study. There's 3 different pieces that we're going to be doing. We're currently looking at folks that have already upsized their panel and doing some analysis to see could they have avoided it and how much would they have saved if they had done that. The next phase will be to recruit folks that are still at 100 amp panels. That's usually the size that we try and see if we can maintain. Let's talk. We need recruits. And then we will down select about 50 of them to actually run this tool on their home and partner with them to decide to go ahead and implement the electrification measures and use it to test the tool out and see if it's working correctly and is able to predict correctly. Definitely lots of support could be used here in terms of identifying people across the state, especially outside of the Bay Area. Love the Bay Area, but we try to get a little bit more. Also in disadvantaged communities and such, and so we have some strategies around that. But also, this grant doesn't actually pay for the electrification measures. Oops. So we have to figure out how to put a funding stack together, and with incentives starting to drop, suggestions, ideas are definitely welcome there as well. And there's some pieces at the end where we're going to spread the word, make sure it's commercialized, set it up as open source so others can build on it, and it becomes a community-based tool. Next slide. So some of the measures we'll be using, folks may be familiar with these. We have a lot of match funders that are going to give discounts on some of the equipment. Discounts are good, but somebody's still got to pay the rest of it. So using smart panels, the smart splitters or the circuit splitters are terrific. The meter collars, assuming those get approved for the different IOUs, and then some of the more efficient, power-efficient equipment. Folks may be familiar with 120-volt heat pump water heaters, the induction stoves that only need 120 volts, and of course heat pumps. We love heat pumps. Okay, so that's one project that I'm working on. I'm helping to lead the field trials there, so that's kind of cool and fun. Different project. Yeah, there's a totally different thing that I'm also working on. I don't know if folks are familiar with AHRI 1380, but this is a protocol that's been put together for demand response for variable capacity heat pumps. I'm actually somewhat new to this industry, so I have to laugh. The big innovation is that they can do high, medium, and low instead of just on and off. Okay, because most heat pumps and most HVAC systems are on or off. A furnace, it's on or it's off. So variable capacity heat pumps can do graduated, high, medium, low. And so this is a protocol where the utility can actually communicate with the heat pump and tell it, we're in a high peak period right now. Can you drop down? And so this is a field study with a particular heat pump manufacturer and one of the utilities in the state to work with either existing installations or some new installations in single-family homes and actually simulate these flex events. Simulated only in the sense that it's not actually a peak demand period. It'll be the real messaging going back and forth. And then doing measurements and seeing how much was actually saved and what the impact on comfort is. Because there's a big issue with retention in these programs. When it's a peak heat day and you've signed up for one of these programs and they just turn off your AC for 2 hours, that's a big ask. But if you can just turn it down, would that be better? It's still running, you're still getting something, but at least it's also, if you get enough people, it can actually make a difference. So they have 2 different levels. We're trying both of them, and we're doing some measurements over a period of several major seasons so that we can see both hot areas and cold areas, and both how much energy did it actually save, and what are the impacts on comfort and retention for these programs. So this one's kind of fun too. Next might be back to Amruta.
Yeah. All right. So In this particular pilot program, so that's a CalNext. I don't know if any of you know of CalNext. CalNext is a statewide, California-wide electrical technology advancement program that TRC is partnering with Energy Solutions and some other partners on implementing it. They do have a focus pilot as one of the streams, as there are research programs, some demonstration programs. Focus pilots are more market transformation focused, where you are looking for ways, what are the current market barriers, and you're addressing those through the demonstrations. And the goal of this pilot program, which is electrification enablement with load balancing technologies. Again, how load balancing technologies or load management can play a role in terms of electrification. Let's say cost-effective electrification in that's the biggest piece. And we are targeting EV because EV is one of the highest loads for customers. Like if you look at their panel, between all the loads, EV would consume majority of your panel capacity. So we are looking for ways like how can you use these load balancing technologies and electrify optimally in addition to your electric vehicles. And many of us are working on that project. So the objective is to enable EV adoption and do additional electrification using load balancing technology without upgrading your electrical infrastructure. So you do an EV adoption with a washer dryer, or with a heat pump water heater, or with a heat pump, and what are those different technologies available, and which market segment would it support. So there is no one size fits all. So we are working with 7 different manufacturers, from smart panels to circuit splitting to circuit pausing to meter collars. And of course, these are all great technologies for a right market segment, and that's the segment we are trying to address through this focus pilot. Next slide. And these are the different load balancing technologies. We are targeting circuit sharing, pausing, meter collars, smart breakers. Smart panels are great, but they're also, we're trying to figure out the cost effectiveness of those. And there are some newer manufacturers who have breakers, smart breakers or smart relays that you could use without upgrading the panels that can be more cost effective. So that's another approach that we are testing. If you go to the next slide. Okay, so I guess we talked about 4 different projects, programs, and this is the last one that I'm going to cover. There is a typo here. It's not effort 7, it's the effort 5. But with PG&E, we are working on residential energy orchestration pilot program. So what's unique about this program is we are trying to address all of the end users in a home and orchestrate them to meet with the utilities total system benefit, or the infrastructure costs. Think of it as time of use or the prices to devices but we are identifying a customer load management program model that would be ideal for PG&E for future programs. We are looking at about 300 homes, and these are going to be working with the owners of existing homes. We're targeting homes that already have heat pumps and heat pump water heaters. So energy efficiency measures we're targeting so that this program could be cost effective. But what we are trying to do in addition to that is making sure that those are controllable, and we can work on orchestrating them through those controls. So right now, some of the questions that we are trying to address are, who are the API platform vendors whom we can work with to orchestrate these different measures? And does a daily load shift make sense? So far, think of any load shifting project is more of a demand response project, and that's all event based. Like you have an event, utility would send signals, and you are reducing. This is something we are trying to do on a very regular basis to see energy efficiency and load shifting benefits on a sustained load shifting. I think that's the last slide. Yes.
Good job. Yay. Okay, so which one's your favorite?
Which program? The 100 amp panel. The panel tool.
The panel tool.
In part because I'm working with so many great groups, including Redwood.
Yes, I would say that because we are working with so many of, it's a collaborative effort, the CEC panel tool. I think it's like it is becoming super interesting because each entity is a leader in what they are doing. So all the great ideas are becoming super. So I would say CEC Epic tool as well. But the PG&E RES CEO has a lot more challenges. So that one is, I would add that as a second one as well.
What are the challenges, Stevie?
Yeah, because, because we are trying to orchestrate all of the end uses. Yeah. The technology it's so cutting edge that nobody has done that before. So, trying to identify, is it the DERM platform vendor? But that might be too expensive, and utilities don't want a DERM platform vendor. So then is it an API platform vendor? And then who are the technologies? Are they controllable? And these are 300 homes. They might have controllable, might not have controllable. So, these are the challenges we are expecting to see pretty soon.
Okay.
Yeah.
Those are real challenges.
Yes. Tanya had a question?
Well, I was going to say about that, I have worked with Emerald back in 2016 on a HEMS program and then tried to commercialize at the residential level.
Cool.
That type of optimization and just the cost effectiveness never was there.
I see.
Too difficult to integrate all of those systems for, a ceiling fan. Like you're just, the difficulty was, you go to a homeowner from the utility perspective and where we can aggregate it at scale and you say, hey, do you participate in our Flex Time Rewards program? And I remember one residential homeowner was like, is that program where you pay me $5 a month to turn off my HVAC on the hottest day in summer? And I'm like, yeah, that's the one. And she's like, F no, why would I do that? I want my house to be cool. But for us, when you aggregate that across our utility, it was literally the most money you could pay for a megawatt. So I was going to ask, at what point do you assess in there sort of like, okay, we could control everything, but what really is cost effective? What is the pathway to cost effectiveness, or what is the right segment, go to market strategy?
Yeah. So one is we are not just load shifting, but we are. It's called we are working on strategies that are like pre-cooling, preheating, so that the comfort impact on the customers would be the lowest. So just working with the, heat pump water heater manufacturers to figure out what are going to be the advanced load up, shared, what are those commands, what makes most sense. But to answer your question regarding cost effectiveness, yes, I totally agree. That's one of the biggest questions in addition to all the challenges that we are trying to solve for PG&E, that what is cost effective, how much should they invest in this for a few megawatts that they might generate. But the fact that there are so many residences, we are optimistic that if we do it right, then there is a path forward. But cost effectiveness is one of the key areas we are trying to. Maybe another, maybe a good discussion point is also something we are internally discussing. Is it the KW, is it the peak, or is it the KWH, or is it the total system benefit that so for example, one of the things that we are thinking of is weatherization, air sealing, duct sealing. But these are all relatively new measures because it's all heat pump water heaters that we already want installed. So it's the controls that we are going to target. So these are like 2019 to 2022 homes. So they're relatively tight. We did some internal analysis on air sealing and duct sealing and did not see much KW or KAWH savings because new houses. But then if I look at the total system benefit, there is there to it. So, those are the kind of what is the criteria we want to evaluate it against. But those are the criteria as we are discussing.
And I would add that these are field pilots, and the idea is TRC is coming in as independent of all these manufacturers. They all have their sales pitch and their specs and good things that they say they can do. But how does it work in the real world? And how do you collect data to answer questions like that? Whether it's the different energy data or the homeowner impact, so that folks can make these decisions and see whether the technology is mature enough to actually move forward or identify the areas that still need more work. Right? Like some of these may not get all the way across the finish line, but they'll figure out what's left to be done, throw it back to industry, and come back in a few years and try again. Right?
So batteries. The virtual power plants that are being deployed around the nation, Texas, Bay Area, et cetera, that I don't think was on the list of the things that you're coordinating, or was that?
So within the home, if a customer has a battery, then yes, battery is going to be within the home, but not the virtual, like not the utility kind of battery, but within the home, we are looking at solar, batteries, water heaters, heat pumps, pool pumps, anything that could be controlled.
The addition of battery and cheap solar seems to what's changed since 2016. And I'm wondering, because it's true, does the water heater really make that much sense? Maybe it's system level, but if you throw in a battery and a solar array on the roof, that's a lot of power that you can make and deploy. And that's the new world that we're in.
Yeah, so that's why we decided to keep batteries. So that, because that's where the future is, so it makes sense for us to analyze it right now.
Got one in the back here.
Can you just briefly describe the meter collar, how it works, and what role it plays?
So meter collar can be used in a couple different ways, but I think the key is that it is able to see the whole home's energy usage. And so one of the roles it can take is to help understand whether you're getting close to your max and to make some decisions based on that. So it really will depend on what else it can control in terms of what it can decide to do. So it can be used for load balancing. For example, there's some meter collars where your EV charger can actually come through there. And so if your house is getting a little bit too high in its usage, actually pause the EV. Okay, you can do that other ways too, but a meter collar is one way. It can also be used if you've run out of circuits in your panel to actually just be a way to get more things to plug into the panel, but while still managing the overall usage. So there's a number of different use cases, but the key is that it can see the whole home in addition to whatever particular controls it's given. And if anybody else has a little more insight that wants to add.
Solar with it?
So it's another way, like if you don't have enough capacity on your panel to add as much solar as you want, it's a way to kind of bypass that, but still follow all the load calc rules. So again, there's several different use cases for them, but the idea is that these meters, the electric meters you have, are actually a socket. So you can pull them out, put this other thing in the middle, and then plug it back in again. And so now it has access to those points and can see what's passing through and make decisions.
And those are approved?
They're working their way through. Some of them are already approved. The solar ones were kind of the first ones, but now some of the others are now, they finally figured out how to fund the lab testing that needs to be done in approval, so I think we'll start seeing more of them soon.
An ad, PG&E will sell 5,000 a year only. So they make meter collars for plugging generators and trucks and things like that, but only they get to put them in. They're not making for the public. It's just like tiny little fringe cases. And then I think Liberty Utility in Northern California, that's a utility that's approved to them. That's the only utility that's approved someone else's stuff.
That has been updated as of the most recent building decarbonization proceeding out of the CPUC.
Right, because they're going to fund.
Exploring the technical feasibility of meter socket adapters.
Yeah, which is the more proper term.
Yeah.
Meter socket adapters.
Yeah.
Yeah.
PG&E has approved a couple different meter collars, and so has, I think, PG&E has approved Teslas already for install, which has a different application.
That's just for
It's
solar.
to disconnect from the grid.
Yeah.
Right? If the grid goes down, it provides grid independence, which can save a lot. I'm going to speak to that a little later this afternoon too. So,
Yeah.
I
Yeah, I hear even Southern California Edison also has some approvals going on, or rather they approved. And then CPUC recently had I guess decision on that, that the IOU should invest more in meter collar research or meter collar validations.
And it was funny, it's like, and if one IOU does it, the others don't have to repeat the exact same tests. They're allowed to use the same results. It's like, give me a break. Yeah.
Yes.
One in back
There's
there.
a question.
Hi, I'm Wayne.
Hi, Wayne.
You mentioned that it was going to take a 40% increase in the grid capacity for it, and that's in 2050. If if that's true, that's only 1.4% per year, so it is doable. So let's not put a roadblock in that. And the other comment is, I think Sean is really on the right track, but also bidirectional charging
Yeah.
of your car, adding the battery from your car is really the cheapest way of adding batteries to the grid. So that should
Yeah,
be
yeah.
The technology is still emerging there in terms of the cars that support it and the glue that you need at your house to route that, but definitely that's a big one coming.
So it won't be part of this study. It's
They
sort of
won't be part of this study, but
Yeah.
yes, there are so many other
hopefully we
studies
don't
that.
have to wait 10 more years.
Going back to meter socket adapters, are there any examples of those in multifamily housing or any, yeah?
I don't know.
anything on that
You
front?
guys know?
I don't know.
Spencer's good on this.
The way the collar works is usually you have to have some kind of conduit moving from the conduit or connection, like a control wire. And because most multifamily properties have like a lot of meters, you can picture like a web of them going across that. And so I don't think there's been
Yeah.
approval there yet, but there's got to be a path. They got to figure out some way to configure it.
Yeah.
In fact, most of them have been approved for single family.
Single
There
family.
was, however, from the same CPUC decision on building decarb, the common facility cost treatment, which is being extended to some multifamily, where you can socialize the cost of service panel upgrades, so they don't have to
Yes.
be borne by the property owner.
Yeah.
So, good news for multifamily, maybe not for all ratepayers, but I think it'll balance out, small.
Well, you guys that charge back on the utility bills of all
Yeah,
the residents?
basically you're like rate basing the cost of multifamily service panel upgrades.
Those different business models and aligning is the challenge. Okay.
All right. Thank you.